Hello all, welcome back to the tutorials. So we will continue our discussion on the Arduino boards. In this tutorial, we will learn more about the pinouts of Arduino and then what inputs can be provided to the Arduino board or what outputs Arduino board is going to give us. So the first thing, this is basic insight into the major serial and GPIO interfaces that are there on the Arduino board. If you see here, so this top section is entirely power and reset signals, and the bottom section, even though it mentions analog, this can be used as these pins can be used as digital IO as well. And then there is a I2C section over here. And on the right, if you see, these all pins can be used as digital IO. And then you have UART here, you can see the TX and RX, and then you have SPI in the middle, and then I2C. So while this gives a basic glimpse of what are the pins that are connected, you can see here this gives us a deep insight into the alternate functions of each and every pin. You can see these basically are power pins, and then these are analog pins, and you can see the STA and SCL, the I2C pins here. And then on the right, if you see, these are the digital pins that are connected, and you have I2C connections, and then it supports PWM as well. And then SPI connectivity is there, and then you have the interrupts here, external interrupt 0, external interrupt 1, and you have the UART pins, basically the TXT and RXT pins. So this gives a glimpse of alternate functions of each and every pin, and then we will talk more about each and every functionality. So if you see here, while using the Arduino board, we cannot use it in whatever way we want. There are some restrictions on the levels that can be applied to Arduino. Like example, on the Arduino pins, you cannot give any voltage more than 5.5 volts. That is the absolute maximum. So you have to limit the voltage to 5 volts, but it can go up to 5.5 volts. And even on the per pin, you cannot give more than 6 volts absolute maximum. So very important point we have to keep in mind, because the first thing that we do is power up the board or connect something to the Arduino pins. So this is very important to remember, point to remember. And then never give any negative voltage to Arduino boards. So why this is mentioned here is, actually what happens is, on the GPIO pins you have diodes internally, and if you give negative voltage, there is every chance that the diode conducts, and it can internally power up other sections. So this is another important point. And then one more important point is, never give power to the Arduino board, never give any signal at specific voltage to the Arduino boards. Like example, we have the pins here, right? Never give any voltage to these pins when the Arduino board is not powered up. This again is the same reason, because of the internal diodes. If it forms a conductive path, there is every chance that the microcontroller unintentionally gets powered up. A major issue, right? I just have, let us assume we have Arduino in our system. We have built a small system in which Arduino is one part of it. And example, if the other boards are powered up and Arduino is not powered up, and if there is some connectivity, some signal from the other boards which pass on to these Arduino connectors, there is every chance that Arduino powers up and it might perform its actual functionality. So a complete completely unintentional scenario, right? And this problem, it's just not with this particular board. You see this in many of the microcontroller boards. And then we talked about this, right? So this snapshot you see here is from 80 mega 328p microcontroller data sheet, where you can see here voltage on a, these are absolute maximum ratings, and you can see it mentions here voltage on any pin except reset bar with respect to ground. So the absolute maximum is VCC plus 0.5. That means 5.5. So you cannot go beyond 5.5 on any of the pins. This might damage the microcontroller straight away. And then we connect number of circuits to Arduino, right? Number of like example, we can drive an LED, we can control something, we can control a relay. There are many things we do, connect some pull-ups. So basically there are n number of functionalities outside. So sometimes because of the load that is connected, sometimes the Arduino board has to sink current, or it has to give out current. So in any case, you can see here the DC current per IO pin absolute maximum is 40 milliamps. So you should not exceed 40 milliamps in any case. And if you see here, for a particular port, the actual current, maximum current is 30 milliamps. So the scenario is, for any pin, you cannot have more than 30 milliamps load that can be connected. So ensure that you do not have this kind of loads where they draw too much current connected to the Arduino board. A very, very important point to remember. And then this is another important point. So there is one pin called IO reference, right? So this IO reference pin is the second pin in this connector, in the shield connectors, right? The IO connectors. So you can see from the schematic snapshot here, this is connected to the 5 volts. So what it means is basically the Arduino board that we have, and the pin IO reference is basically a output from the Arduino board, and it's not input. So IO reference name is little confusing for people who are referring the schematic. So understand that this is a 5 volts output, and it acts as a reference to the shield that is connected on the top of this Arduino board. So a very, very important point to remember. And then another important point is, in the same power connector you have VIN. VIN is nothing but a pin to which you can apply voltage to Arduino. That means 5 volts. So if you connect a shield on top of this Arduino board, you can provide power to the Arduino board from the shield without even connecting the DC jack or the USB. So that means the Arduino board can be connected by the shields that can be that get mounted on top of the Arduino board, right? So another important point. So if you are new to Arduino and if you are listening this for the first time, you can see why this board is so popular. And we will talk about many things in the coming videos, and will be amazed at the capabilities, at the community that Arduino board has right now, and how popular it has become. So stay glued to our channel. Please visit us for more videos. Thank you.